That heavy black box tucked under the hood of your car isn't just a component, it's a planned expense, a subscription service you didn't know you signed up for. The entire automotive industry, from the manufacturers to the auto parts stores, has masterfully conditioned you to accept a simple, profitable lie that a car battery is a disposable item meant to die every 3, maybe 4 years if you're lucky. They've framed it as a consumable, just like your oil or your tires. But what if I told you that this belief is one of the most lucrative falsehoods ever sold to car owners? What if the key to making that battery last a decade or more isn't some complex, expensive secret, but a series of simple disciplines they hope you never learn? They are counting on your ignorance to fuel their bottom line, selling you replacement after replacement. Today, we break that cycle. If you're ready to stop handing over your hard-earned cash for a new battery every few years and start treating your car like an asset, not a money pit, then do me a solid and hit that like button and subscribe to the channel. What I'm about to share will fundamentally change how you view your car's electrical system forever. Let's get into the secrets that will keep that battery alive and kicking for a decade. Number 1. Conquer the silent killer: heat. Before we talk about charging, testing, or cleaning, we have to address the number 1 enemy of your battery, the assassin that works in silence: heat. A car battery is essentially a box of controlled chemical reactions. Its job is to store and release electrical energy through the interaction of lead plates and sulfuric acid. Like any chemical reaction, heat acts as a catalyst, dramatically accelerating the process. While this might sound good, it's actually incredibly destructive. An engine bay on a hot summer day can easily exceed 140 or 150 degrees Fahrenheit. At these temperatures, the chemical reaction inside your battery goes into overdrive. This causes 2 catastrophic problems. First, it accelerates the evaporation of the water from the electrolyte solution. This is especially critical in non-sealed, serviceable batteries. As the water level drops, the acid becomes more concentrated, and the tops of the lead plates become exposed to air. This exposure causes irreversible damage to the plates, permanently reducing the battery's capacity to hold a charge. Second, the high heat speeds up the natural corrosion of the positive lead grids inside the battery. Think of it like metal rusting in fast forward. As these grids corrode and weaken, the battery's internal resistance increases, and its ability to deliver the massive amperage needed to start your engine plummets. It's a slow death that you won't notice until that one cold morning when all you hear is a click. So, how do you fight this invisible enemy? It starts with simple habits. Whenever possible, park in the shade or in a garage. This simple act can lower your engine bay's ambient temperature by 20 to 30 degrees. If you live in a perpetually hot climate like Arizona or Texas, consider investing in a battery heat shield or an insulating sleeve. These are often made of reflective, heat-resistant materials and act as a protective barrier, deflecting radiant heat from the engine and exhaust manifold. Many modern cars, especially those with batteries in the engine bay, come with a plastic or fabric insulator from the factory. Never remove it. It's not there for looks, it's a crucial component for longevity. Here's the technical information for the editor to highlight. The ideal operating temperature for a lead-acid car battery is around 73 or 25 degrees. For every 15 degrees or 8 degrees increase in the average operating temperature, the battery's service life is cut in half. So, a battery that might last 8 years in a cool climate could be dead in just 2 years in a hot one if neglected. Number 2. Become obsessed with voltage. You wouldn't drive your car without a fuel gauge, so why are you managing your battery without one? The single most important tool you can own for battery health is a simple digital multimeter. They are inexpensive and will become your best friend. A battery's voltage is a direct window into its state of charge, or SOC. Understanding these numbers is non-negotiable if you want a 10-year battery. A fully charged, healthy 12-volt lead-acid battery should read between 12.6 and 12.8 volts when the car is off and has been sitting for at least an hour. This resting voltage is key. Checking it right after a drive will give you a false high reading from the alternator's surface charge. If your battery consistently rests at 12.4 volts, it's only at about 75% charge. At 12.2 volts, you're down to 50%. And if it ever rests at 12.0 volts or below, you're in the danger zone. The battery is considered fully discharged, and at this point, a process called sulfation is happening at an alarming rate. We'll get more into that later, but just know that allowing a battery to sit in a discharged state is like leaving a deep wound untreated. It will lead to a premature death. Get into the habit habit of checking your battery's resting voltage once a month. It takes less than 30 seconds. If you find your battery is consistently low, it's an early warning sign that something is wrong, either with your driving habits, your alternator, or a parasitic drain. This proactive check allows you to fix the root cause before it destroys the battery itself. Number 3. Hunt down parasitic drains. This is especially critical for anyone with a used car. A parasitic drain is an electrical load that draws current from the battery even when the ignition is turned off. All modern cars have a small, acceptable amount of parasitic drain to power things like the clock, radio presets, and the security system. However, when a component fails or an aftermarket accessory is installed incorrectly, this small drain can become a massive, battery-killing vampire. Think of a faulty trunk light that never turns off, a short in an aftermarket stereo amplifier, or a malfunctioning control module. These things can suck a healthy battery dry in a matter of days or even overnight. The multimeter you bought for checking voltage is also your weapon for hunting these drains. The process is a bit more involved, but it's something every car owner should know how to do. You're essentially going to put the multimeter in line with your battery's negative cable to measure the amount of current, or amps, being pulled when the car is completely asleep. A normal drain on a modern vehicle should be between 20 and 50 milliamps, 0.02 to 0.05 amps. Anything over 100 milliamps, 0.1 amps, indicates a problem that needs to be found and fixed immediately. To find the culprit, you can then pull one fuse at a time from the fuse box until you see the amperage reading on your multimeter drop significantly. When it drops, you found the circuit that's causing the drain. This test can single-handedly save you from replacing battery after battery, mistakenly blaming the battery itself when it's just the victim of a hidden electrical fault. Set your digital multimeter to measure DC amps, usually the 10A setting. You may need to move the red probe to a different port on the multimeter labeled 10A. Ensure all doors are closed, the key is out of the ignition, and everything is off. You may need to trick the car into thinking the doors are closed by manually latching the door lock mechanism with a screwdriver so the dome lights turn off. Wait for the car's modules to go to sleep. This can take anywhere from 5 to 45 minutes. Carefully loosen and disconnect the negative battery terminal clamp. Do not disconnect the positive. Connect the multimeter in series. This means touching one probe of the multimeter to the disconnected negative battery terminal clamp and the other probe to the physical negative battery post. The multimeter is now completing the circuit. Observe the reading. If it's above 50-80 meter, 0.05 C2 after the car has gone to sleep, you have a drain. Start pulling fuses one by one until the reading drops to normal. The label on your fuse box cover will tell you what each fuse protects. Number 4. The charging system is not a battery charger. This is a fundamental misunderstanding that kills millions of batteries. Your car's alternator is a recharger, not a charger. Its primary job is to run the car's electrical systems once the engine is started and to top off the small amount of charge used to start the car. It is not designed to recharge a deeply discharged or dead battery. Forcing your alternator to do this is like forcing a marathon runner to sprint the entire 26 miles. It will overheat and fail prematurely, and in the process, it will likely damage your new battery by improperly charging it. When a battery is deeply discharged, from leaving the lights on or from a parasitic drain, it needs to be recharged slowly and properly with an external smart battery charger. These modern chargers use a multi-stage process that gently nurses the battery back to health, often including a desulfation mode, a bulk charging phase, an absorption phase, and finally, a float or maintenance phase. This is the only correct way to recover a dead battery. Relying on a jump start and a 30-minute drive is a recipe for disaster. That drive will only put a surface charge on the battery, leaving it in a chronically undercharged state, which, as we know, leads to deadly sulfation. A good quality smart charger is an investment that will pay for itself the very first time you use it, instead of buying a new battery. Highlight for the editor. The key is a multi-stage smart charger, sometimes called a battery tender or maintainer. Look for features like temperature compensation, desulfation modes, and compatibility with your battery type. Flooded, AGM, gel. Never use an old-school, high-amperage, unregulated shop charger unless you're watching it like a hawk, as it can easily overcharge and boil the battery. Number 5. The slow cancer of sulfation. We've mentioned this word a few times, but what exactly is it? Sulfation is the #1 one cause of premature battery failure, and it happens every time your battery is not at a 100% state of charge. Inside your battery, the lead plates are submerged in an electrolyte, sulfuric acid, and water. As the battery discharges, small, non-conductive lead sulfate crystals form on the surface of the lead plates. This is a normal part of the process. When you recharge the battery, these crystals are supposed to dissolve back into the electrolyte. However, if you allow the battery to sit in a discharged state below 12.5 volts for any length of time, or if you consistently undercharge it with short trips, these small crystals begin to grow, harden, and merge. They form a stable, crust-like barrier on the plates. This is irreversible hard sulfation. This crust does two terrible things. It acts as an insulator, preventing the battery from accepting a full charge, and it reduces the active surface area of the plates, crippling the battery's ability to deliver current. The result? Your battery seems weak, it dies quickly, and eventually, it won't hold enough charge to start the car at all. Fighting sulfation is a daily battle. The best defense is to always keep the battery as close to fully charged as possible using the methods we're discussing. For batteries that are already starting to show signs of weakness, some advanced smart chargers have a reconditioning or pulse mode that uses high-frequency electrical pulses to try and break down and dissolve some of this hardened sulfate buildup. It's not a miracle cure, but it can often extend the life of a neglected battery. Number 6. Practice. Perfect hygiene. A dirty battery is an unhappy battery. Over time, a fine layer of grime, acid residue, and moisture can build up on the top of the battery case. You might think this is just a cosmetic issue, but it's not. This layer of dirt can actually become conductive, creating a tiny electrical path between the positive and negative terminals. This results in a slow, constant self-discharge, a mini parasitic drain that you created yourself. The fix is simple and cheap. Once every 6 months, clean the top of your battery case. This simple cleaning ritual prevents the green and white corrosion cancer from forming and ensures a perfect low-resistance connection, allowing the battery to charge and discharge with maximum efficiency. Number 7. The stability secret. This is one of the most overlooked aspects of battery maintenance. Your car's engine creates a significant amount of vibration. A battery is a delicate assembly of thin, heavy lead plates packed tightly together. If the battery is not securely fastened down, the constant, violent vibration from the road and engine will physically damage those internal plates. The plates can crack, the welds connecting them can break, and the active material on the plates can be shaken loose, creating a sediment sludge at the bottom of the battery case. If this sludge builds up high enough, it can short-circuit the plates, killing the battery instantly and without warning. Every time you're under the hood, give the battery a little push. It should not move at all. If it does, your battery hold-down clamp is loose. This clamp is a purpose-built piece of hardware designed to lock the battery firmly in place. Tighten it down. It's not just a suggestion. It's a critical component for ensuring the battery's internal structure survives the harsh environment of a moving vehicle. This is a very common issue on used cars where a previous owner or a lazy mechanic failed to properly reinstall the hold-down after a replacement. Number 8. The driving dilemma. Your driving habits have a direct impact on your battery's lifespan. Starting your engine is the single most demanding task your battery performs, requiring a massive burst of hundreds of amps for a few seconds. After this huge withdrawal, the alternator needs time to replenish that energy. The problem is, many people only use their cars for short trips, a 5-minute drive to the grocery store or a 10-minute commute to work. During these short drives, the alternator doesn't run long enough to fully recharge the energy used to start the car, let alone run the lights, stereo, and air conditioning. Each short trip leaves the battery slightly more discharged than before. Do this day after day, and you are chronically undercharging your battery, which invites sulfation to set in and destroy it. The solution is to ensure the car gets a good, long drive at least once a week. Aim for a continuous drive of at least 30 to 45 minutes at highway speeds. This gives the alternator ample time to do its job and bring the battery back to a full state of charge, effectively boiling off the soft sulfate crystals and keeping it healthy. If your lifestyle simply doesn't allow for this, then you are the perfect candidate for using a battery tender. Hooking up a smart maintainer once or twice a week will perform the same function, keeping the battery topped off and ready for service, preventing the slow death caused by a short trip lifestyle. Number 9. The myth of maintenance-free. Let's be clear. The term maintenance-free on a battery battery is a marketing gimmick. It simply means the battery is sealed and you cannot add water to it. It does not mean you can install it and forget about it for 10 years. Every single principle we have discussed, avoiding heat, monitoring voltage, cleaning the terminals, ensuring a proper charge, checking for vibration, and hunting parasitic drains, applies just as much, if not more, to a sealed, maintenance-free battery. In fact, in some ways, they are less forgiving. In a traditional serviceable battery, if you overheat it and boil off some water, you can top it up with distilled water and potentially save it. In a sealed battery, that water is gone forever through its pressure vents, and the battery's life is permanently shortened. Treat the maintenance-free label with suspicion. It's an invitation to neglect, and neglect is what sells new batteries. True maintenance is a discipline, not a product feature. This also applies to modern AGM, absorbent glass mat batteries. While they are more resilient to vibration and have different charging requirements, they are still susceptible to death by heat, chronic undercharging, and parasitic drains. Number 10. The jumpstart catastrophe. Sooner or later, you might need to jumpstart your car or help someone else. Doing this incorrectly is like performing surgery with a sledgehammer. You can cause catastrophic damage to the sensitive electronics in both cars, not to mention the batteries themselves. Modern vehicles are packed with computers, ECUs, TCUs, BCUs, that are extremely sensitive to voltage spikes. The most common mistake people make is connecting the jumper cables directly from the good battery's positive to the dead battery's positive, and the good battery's negative directly to the dead battery's negative. This is wrong and dangerous. Connecting the final negative cable to the dead battery's negative post can create a spark. A discharging battery can release hydrogen gas, which is highly explosive. That spark can cause the battery to explode, showering you and the engine bay with sulfuric acid. Here is the correct, safe jump-starting procedure for the editor to highlight. Park the good car close enough for the cables to reach, but do not let the vehicles touch. Turn off the good car, connect one red, positive clamp to the positive plus terminal of the dead battery. Connect the other red, positive clamp to the positive plus terminal of the good battery. Connect one black, negative clamp to the negative terminal of the good battery. This is the crucial step. Connect the final black, negative clamp to a large, unpainted piece of metal on the engine block or chassis of the car with the dead battery, away from the battery itself. A common spot is the alternator bracket or a dedicated grounding point. This is your ground connection. Start the car with the good battery and let it run for a few minutes. This provides a charge to the dead battery. Attempt to start the car with the dead battery. If it starts, let it run. Remove the cables in the exact reverse order. Disconnect the black clamp from the engine block first, then the black from the good battery, then the red from the good battery, and finally the red from the what was dead battery. Following this procedure prevents dangerous sparks near the battery and protects your vehicle's delicate electronic components from voltage spikes.